Welcome, engineers. My name is Travis IQ, and today we are doing CCNA subnetting questions. I'm going to walk you through the answers, how I think through them, and how I come to these conclusions. Let's do this. So we are back in the void discussing CCNA topics, specifically subnetting. And I am going to start here as if you completely understand subnetting, and I'm going to go into some detail about how I answer these questions with my knowledge of subnetting. If you have questions about the specific methodology of subnetting that we're using here, which is block size, I would suggest that you take a look at the video that we previously posted. I will put a link to the video in the description below if you want to take a look at that, if you feel a little overwhelmed by the descriptions and discussion we're having here. So let's start with this question. You're a network technician, you're installing a new workstation, the relevant network segment is shown below. I'll give this in a little bit more clear description, 192.168.5.33. And so we're going to use this slash notation here to describe the size of this network. And so I'm actually going to put my little block size chart over here. So we're going to go /24, /25, /26, /27, /28, /29, and /30. These are all of the network sizes that would exist inside of a class C, which is a /24. And so the block size of a /24 would be 256 hosts, obviously, but I mean that would actually exist on one of the octet boundaries. And so a /25 is actually going to be a 128 block subnet. A /26 is going to be a 64, not 100, it's going to be a 64 block subnet. A /27 is going to be a 32 block subnet. /28 is going to be a 16 block subnet. A /29 is going to be an 8 block subnet. And a /30 is going to be a 4 block subnet, right? So there's going to be a block of 4 addresses in this /30. But anyway, we're not in a /30, are we? We're in a /28. And so that means that every 16 addresses is going to net me a new address or a new network, right? So we'll start with a 0. So 0 through 15 is one network. 16 is the next network. 32 is the next network. And 48 is the next network. And if we look at this relevant network segment here, we have 192.168.5.33. That means that they're showing you the address on this router here, this router interface. That means that the first address in this .32 network, so this is the network ID, is the default gateway. And that means that I have to find one valid address in here that lives in this address space to give to this host. So let's go through the list here. So 192.168.5, 192.168.5, right, with a /28, that means that the first 3 octets are never going to change. That's what that definition means for us. So 192.168.5 is 192.168.5, so I actually don't have to worry about the first 3 octets in any of this stuff. All I have to do is worry about the last octet. So the 55 host does not exist between 32 and 48. 47 really is the last address in the space. It's not usable, but it is the last address in the space. So 48 through 64, it's actually going to exist in the next network up. So this is not valid in this network that was described to us here. 192.168.5.47. 47 is the last address in this space. This is actually a broadcast address for that network. And again, if you're confused about broadcast address, network ID, and whatnot, I would point you in the direction of the video, one of the previous videos that we've done, which will be linked in the description below. This is the broadcast address, so this is not valid either. .32, we already said, is the network ID. That's not a valid address. I can't give a host the network ID that identifies the network. .14 isn't within this address range either, 32 to 48. 14 is all the way down here, so that's not valid. The only valid address for this network described above is C, 192.168.5.40. That exists right in here, and that is a valid host address. Every other one of these, you might have said to yourself, Travis, they're going to give me 5 addresses here and only one of them is going to be valid. They all look pretty darn close. That's actually correct. There is only one valid host, and it is C. All right, let's take a different approach. So instead of using the slash notation or hack notation that a lot of us network engineers are familiar with. Let's use the standard subnet mask. This is 255.255.255.224. I am still going to use my block size notation. And then I'm going to look up here and I'm going to say 255.255.255.224. So this is 24 bits here, 24. And then the 128 bit is on, the 64 bit is on, and the 32 bit is on. So this is actually a /27 because there's 27 bits that are being allocated to the network. And I could have told you that I identified this by memory as the /27, or I could have described it to you here, which I have chosen to do, which is give you a brief description of why it's actually a /27. So that's a /27. This means that my block size is 32. So this is a block size of 32 for any of these networks here. For any of these host addresses, right? Or maybe they're not valid host addresses. Any of these IP addresses, the network or the block size of addresses is going to be a 32 block of addresses in the 4th octet. How do I know it's the 4th octet? Because 255.255.255 indicates to me that the first 3 octets are not changing. And so which of the following addresses can be assigned to network hosts given a subnet mask? By the way, then, any of these 201.45.116, 134.178.82, 192.168, that's in the private address space, 92.11, 217.63.12, none of these are indicating to me that they can't be assigned to hosts. We could say, like, if it were like the 127, like the loopback address space, maybe that would also prohibit it, but we don't see any of the 127s here or any of these really unique spaces. So any of these are valid first 3 octets. So what that means is I actually still just need to look at the 4th octet here. And I need to determine if these are valid host IPs with 32 address block sizes. What does that mean? Are they valid host IPs with 32 address block sizes? Well, it means that each network is 0, 32, 64. These are the boundaries of the networks. 96, 128, because their block size is 32. And then I have to define that the network ID and the broadcast ID are not usable. And so if these aren't usable, what they're really asking me is they're saying, hey, how many of these addresses don't fall on that network ID, broadcast ID boundary that I said is not usable? And so we have to go through for each one of these and look and determine this. And actually the 159 address is even higher than 128, right? So 128 plus 32 is 160. And so it's asking me, is 159 between 128 and 160? It is, and it's not 159, which is the broadcast. It's actually the last, oh, it is 159. Right? So I believe I might have said 158, but actually 159 is the broadcast. This is not valid, so I am not going to mark this. Which of the following addresses can be assigned? This cannot be assigned, so I'm not going to check that. 62. Remember I said I'm just looking at the last octet. 62 is between 32 and 63, which is the last IP in this space. 62 is actually the last valid. 63 is the broadcast of the 32 network. And so 62 is a valid host. So 134.178.18.62 is a valid host. If I were to describe this network like this, what it's actually asking me is if I describe the network like this, 134.178.18.0/ actually not 0, is it? .32/27 is 62 valid in this space? And the answer is yes. Next up, 192.168.16.91. We're looking at the last octet, the 91 octet. Where does 91 fall? It falls between 64 and 95. 91 is right here. 91 is not 64. It's not 95. That means that it is valid. 192.168.16.91 is a valid address in the 192.168.16.64/27 address space. 92.11.178.93. 93 is in this 64 to 95 range. It actually falls right in the middle of that range. It is not a broadcast address or a network ID. This is also valid. 217.63.12.24. Where does 24 fall? 24 falls between 0 and 32, right here in the middle. And it's not 31 and it's not 0. This is also valid. And then finally, we have 15.234.118.63. And we said the first 3 octets don't matter. The last octet here, the 4th octet, is .63. That means that .63 is between 32 and 64. It falls right as that last address, which is the broadcast ID, which is not valid. This is not a valid address. So there's only 2 addresses that are not valid given this subnet mask and the associated block size that I determined from that subnet mask. Question number 3. Consider 192.168.15.19/28. So this is a valid host within the /28 space. Which of the following addresses are valid host addresses on this subnet? So what it's actually asking us to do is, with this host and this subnet mask, to determine what network we are in, and then go line by line and determine whether any of these hosts are within this network. So the first thing that we need to do is we need to, as you have seen me do before, write out my subnet masks and block sizes. That's a 7. And I'm just going to go up to 28 because that's where we are here. 128, 64, 32, 16. And this is a network size of 16, right? So 16 blocks of addresses. So we have 0, 16, 32. Where does 19 fall? It falls between 16 and 31. So the valid set of addresses within 16 and 31 are actually 17 to 30. And it's 17 to 30 in the last octet. So 19 is a valid address in this range. And the first 3 octets must be 192.168.15, and they cannot change. So if we look here, actually all 3 of these addresses are 192.168.15. Why am I verifying this in the first, second, and third octets? Because if you were to take this on a test, let's say a CCNA or a Network Plus or something that is network and subnetting based, then these 3 octets are important to you, and a tester or a test maker may vary these 3 octets just to keep you on your toes. Even though you know that they have to stay the same, they may vary them in the answers. If this were a .16, you might not notice it, and then you would get the question wrong. So I encourage you to be very explicit with the way that you approach these questions as well. That's why I am doing this, why I'm writing these things out for you here, is teaching you the best way to go through these questions, be explicit, and ensure that you get them right, because you want to maximize the amount of points you will get, let's say, on a certification exam, or if you're a network engineer and you're doing this in real life, you really don't want to mess this up. And so there's a reason why these exams are so explicit and annoying in their detail. It's because network engineers must be annoyingly detail-oriented as well, which I am. All right. 192.168.15.17. Is 17 valid? Which of the following addresses are valid hosts? 17 is a valid host in this range that I've defined. And once we do all this work, what I've shown you here, it's actually a pretty easy question. .0 is not valid. .29 is valid. .16 is not valid. That's the network ID. That's not a valid host. And .31 also not valid. That's the broadcast. So there's actually only 2 valid hosts here, interestingly enough. And our last question is a word problem, which is typically more complex than the previous problems that we have solved, because we actually have to take the words and put them into objectives and then solve the problem. So we have a law firm in 3 different countries. 2 of the offices have network connectivity to each other. The 3rd office has recently received a router. So we have router 3, which is the office that has recently received a router. The names of the routers are R1, R2, and R3. We need to configure R3's IP addresses, E0 and S1, so that E0's interface receives the first usable subnet. So this is the first usable subnet. We'll define what that means in a second here. And S1 receives the second usable subnet. This is subnet, not address. So we'll just call this second subnet. And it says usable here because if we look down further, the 0 subnet should not be used. So the first usable is actually not the 0 subnet, it's actually something above that. And then the second usable would be the next address above that. Let me come back here to one more objective. Both interfaces, so this is another extremely important component, should receive the last available IP of the subnet. So now we said we defined what subnet they should use, and they should both use the last available IP. This is extremely confusing. Number one, you will see folks in industry give you confusing objectives. Number two, again, in an exam format like this where I'm asking you a question and trying to be a little bit tricky, I'm going to give you the objectives probably out of order to some extent as well, which is what's being given here. So I need to define the subnets. So I have the 192.168.101.0 first usable subnet, while S1 uses the second usable subnet from the network 192.168.101.0. And these are /28 networks is what they've asked me to define. And so if these are /28 networks, then the first network is the 0 network, and we said /28 is a block size of 16. So the next network is 16, and the network after that is 32. And so the first network is the .16 network, and that means that the valid range of that network is, so first network is 192.168.101.16 through 31. That's the whole range of the first network. The second network is 192, second usable, I should say, 168.101.32 through 48. Actually, 48 is the next network, through 47. And so we said 31 and 47 are not usable. So the addresses that I'm looking for are the .30 address and the .46 address. And we said E0 uses the first usable subnet. So the first usable subnet is 192.168.101. And the first usable subnet is the .16 subnet, and the last usable address in that subnet is .30. And the second usable subnet is the 192.168.101.32, which is what S1 should get, the second subnet with the last address in that space, 46. 192.168.101.46. And so this is how you would answer a complex word problem as well. And we are going to continue with this series. I actually really like this, thinking through and engaging with word problems, well-written problems that would be representative of both exam questions and objectives that you might need to meet in the real world. As is always the case, engineer, break stuff, have fun. We'll see you next time. Let's go.